Welcome to Team 14's Greenhouse Design Briefing. Team members from Team 14, from left to right, are Levi, Bennett, Avi, and Hari. Our problem statement: botanics greenhouse teams and home gardening customers need a way to maintain consistent environmental conditions in a small greenhouse environment, such as indoor gardens, backyards, and balconies. Inconsistent conditions like fluctuating light, temperature, humidity, and soil moisture are harming crop health and reducing yields. This problem is important to solve because different plants have specific environmental requirements, and without a way to continuously monitor these conditions and receive real-time information, both inexperienced and experienced growers struggle to ensure their plants remain healthy and productive regardless of their location or residential environment. What are we solving? In a standard greenhouse, there's a lack of use of vertical space. Moreover, there's a lot of inconsistency in various aspects of the design of a regular greenhouse. Our job was to redesign them to create a more consistent and effective greenhouse. Our targets: space use. We wanted to create a design that could efficiently use all of its space efficiently to grow cucumbers, our selected plant. Durability. We wanted to create a greenhouse that was sturdy and could withstand strong winds and weathers with a strong frame. Temperature control. We wanted to make a design that could easily control temperature with ventilation and natural heating. Alarm system. We wanted to create an alarm system that would not only alert the owner of a non-ideal temperature, but also automatically trigger the opening and closing of vents. The initial design and iteration 1, our first ideas. These are our early ideas. In the top left, we have a honeycomb-like structure. In the bottom left, we have a cell block structure. And in the right, we have a purple light system cone. Our selected design. We decided to go with a slightly modified version of our honeycomb structure design, merging with the idea of the purple glass from the cone idea. Shortcomings. The glass would have been too fragmented to work with, making manufacturing very difficult. Proportions were very difficult to design, and the complicated structure meant we would need to use a lot of materials. The purple tint, after doing further research, was revealed to not have very reasonable impact, so we decided to scrap the idea. Iteration 2, starting from scratch. Redesigning. We decided to scrap our idea and start fresh with a completely new base and work with that. Starting with the base idea of managing temperature reliably, we decided to have several cooling/heating features. After refining our ideas by discussing with other groups, among ourselves, and with the administration, we built upon and polished our idea. Final design. This is our CAD design. Our final design incorporated evenly spaced shelves for the soil beds to be planted in. It is a 12 by 12 by 12 feet cube structure with the two middle tiles in the front acting as doors. In this image, one is open and one is closed. It also has a hinging roof to let any debris that collects on top to be dropped off quickly and effectively. The frame is almost like a cage structure. The TI kit aspect is designed to detect if the temperature falls out of the ideal range and triggers a buzzer if that happens. Furthermore, it does something similar with the humidity. These can further be routed to manipulate the ceiling, vent, or fans in future designs. This is some data supporting our final design. Integration 2. We had many new features for Integration 2, including opening triangular vents near the top for easy release of hot air, opaque tiles that reflect light creating a more cool, stable, and manageable temperature, foil on the back of the opaque tiles to reflect light, ensuring even light distribution, fans near the top to facilitate ventilation, pistons to help automate the debris cleaning of the roof detected by change in temperature, a temperature detection system ensuring stable, ideal conditions for the cucumbers to grow. The total cost? This would be the total cost of all of our structural materials. 3D printed fan. Our fan design helps to stabilize the humidity and the temperature of the greenhouse. It adds ventilation and airflow so that the user can control and monitor it. It will be connected to the main system that displays the humidity and temperature. For our prototype, we do not yet have it printed out. Thank you for watching.